Okay. So you had a question, so let's hear you. I'm recording.
So that wasn't really a question. I was only trying to see if I can re-explain the
Okay, go ahead.
the phenomenon. Okay.
Go for
I
it.
was saying that would be represented by a raster model that has certain values.
And what are these values? And what are these values?
Those values are the basics. Those values are the basics.
No, you see, let me tell you something. Remember this model in GIS, the model represents reality. So this is something everyone in the class should put in his mind. There's reality. The earth, where I'm sitting now, me, I'm reality. My location now, where I am, where you are, that's reality. What GIS is doing that is trying to represent this on the computer, which is a very small thing. Computer is small. Or paper, let me just say paper. Are you with me?
Okay.
So how is it doing it? It's doing it two ways. It has the vector approach, which uses points, lines, and polygons, which has some disadvantages and advantages. And then optionally it has raster model, which is actually like taking a picture, right? But one of the beautiful advantages of the raster model is its ability to represent continuous data. And this afternoon, we are talking about surfaces, which seem to have values across their extent of the phenomenon. So when we talk about surfaces, literally, we are not saying raster, but raster seems to be the ideal way to represent this, if you ask me. And it's, of course, later on, we can also ask a question. It's subject to the resolution. Remember, we also talk about the size of the squares. Isaiah, remember we talked about the squares. So
yes.
All that we're talking about, please, let's try and follow. It's a story. From day one to now, I'm telling the story. We are making the story more and more interesting. Don't miss out. They all join up. All the story, the pieces join. It's okay. All right. So that is basically it. It's okay. So we can create different. In fact, we can have probability of lightning strikes. So someone will be thinking, in fact, how many of you have heard that when you go to the northern part of Ghana, there's this myth that they can, do some, some, I don't know, spiritual stuff to, then a lightning will come and strike you. Yes. I mean, it's like superstition, but sometimes there's a reason for it. It could be that the concentration of lightning strikes, are you okay? The density or the friction between clouds there makes it likely that you have lightning strikes there. So the probability that you get stricken by lightning over there is high. It's not everything we should spiritualize. We all have a spiritual side to ourselves, but we can also apply some wisdom to it and say that the chances of a lightning striking out there is high. And don't forget that the terrain at the northern part of Ghana is relatively flat from the pictures I've seen and from what I know. So in Kumasi like this, where we grew up, after school, we go down the slope. Then we just go and you have to just go up again the slope to get to the next town, which means that there's what we call the undulation. Are you okay? So we have to be able to attach some explanation, scientific explanation to all this. Is that okay? All right. Surfaces can be represented using, so this one we know it's already, I'm repeating it. So take notes. I think it's gone. Let me get it again. Surfaces can be represented using contour or isolines. So in this class, I've asked what are contours? Did I ask? It wasn't this class, was it? What are contours again? I don't think it was this class, was the other class. What are contours?
I said they are imaginary lines above
passing through places of equal height.
I show differences in height above sea level.
They don't show differences in height. They show There are imaginary lines that pass through places of equal height. Is that not what we know, right?
Yeah.
Not difference height. When we do leveling, we get differences in elevation. Leveling gives us that. But those differences now allow us to compute the height above a datum. So these lines pass through points of equal height above a datum. Example will be mean sea level. Is that also? All right. So we can represent surfaces using contours. We are not talking about the height above a datum. We are talking generically about values that can be measured with reference to a particular common point or origin. Okay, so in that case, the no datum subcoming. In other words, contour lines can be used to represent more than just height above the height of places. That is the point being made here. Okay, so another name for contour will be isoline. Okay, isolines. Okay, so how do you represent a surface using a contour? Practically, if I go to my whiteboard, which has disappeared, where did it go? Okay, there you are. Let me wipe my board. Okay, so you see that for a contour, you have one contour line looking like, if I depend on the shape of the contour and how the lines are going, you know exactly what the object is. So this one is looking more like a conical hill, and it can also be a depression. Are you okay? Depending on the value. If the values are actually going up 50, 60, so the contour interval is 10, 80. All right. So if you excuse for all the cartographic errors, then this is a contour. And it represents a surface, okay, of values, typical values being 50, 60, 70. We can say that 75 is in between 70 and 80. So the 75th values are going to be around this place. Okay, if you can see my shading, 75th values, so between 71, 72, 70, that's the area that I'm indicating. And within the extent of your project, this is the only area where you find such values, except if you start having a drop again. Okay, so if you're going to have a drop, then in that case, another contour may be passing, which is probably of a lower value, 70. Okay. So then in that case, you can have another one. So in that case, you're having some kind of a hill that drops and it rises again. All right. With some kind of depressed area, an area which is quite low. I wouldn't call it a valley. Yeah, or you could even call it that. Okay, but it's more of a cone. It's like a cone. Are you okay? All right. So that is it. It's not really a solid. Even though I keep saying valley and those things, that's because we can easily associate surfaces. The best surface that we can relate with is the surface of the earth. That is why by default you are tempted to talk about valley and things like that, land, topography and those stuffs. But then there are other surfaces which can be derived of, you know, different values, like even dollar amounts. How much does it cost me? You can create a surface for it. Okay. Uber can do it based on the data they have, that if taxis pick people, how much do they collect? Okay, where do people go to when they pick Uber? You can create a whole model for it and start making money out, taking advantage of that result. And of course, we are not here for that. We are here for in the engineering aspect. So you pay attention to say contours, yeah, as the way you know it, elevation of points above a datum. Arrays of points. What's an array? An array is just in a properly arranged objects. Open objects are arranged in a certain order. Then you have an array. Are you okay? All right. So we're having a regular, you know, regularly dispersed points. Are you okay? So let's go to my whiteboard again. Okay, so where is it? Oh, I'm actually there. Sorry. I thought I left the place, so I was doing something else. So instead of us representing what we see up there with lines, we can just do an array of points. Now remember, to be able to make contour lines, you have to, what do you need? Anybody knows what you need to make contour lines? How do you need to draw contour lines?
So you need your grid lines.
Thank you very much. And the intersection of the grid lines, you measure the height, is that not so?
Yes,
okay,
sir.
so if you have your grid lines, you can see that that's the array of points. They are going to be here. So these are the array of points. And the array of points without drawing the contour line also tells you or try to represent a surface. Is that okay? So in other words, I'm not just going to put these round things there around it. I'm also going to write the value there. So 22.1, 31.8, 99.8, 71.8, 11.1, 12.28. So this is what a surveyor initially obtains. So I'm talking about physical without looking at, you know, criminal activity and temperature. So this is just physical. It's all right. 14.8. So assume we are not using a GPS to measure heights, damping level to measure heights, but rather we are going with a handheld thermometer that can measure the temperature at a place. And we are moving in a systematic order. We'll have the same grid. Okay, I'm just trying to put some values so that you understand. Writing a lot of numbers like that is not easy. Okay, great. So now that is also a way to represent a surface. But which one is better? The contour or the grid? The array of points. Which best represents the surface? And why? Okay, we start with Kofi. Then we go down.
I think the contour, because when you talk about the Earth, the contour really represents the Earth, as referred to the Earth, but the array, you cannot have a land which is, let's say,
Kofi, I think your answer is right, but your explanation is a bit iffy in the sense that you see that look at the contour lines, they almost tell you that whatever you are looking at is like this. So it's not giving you the shape of the object in a way, right? It is, isn't it? Meanwhile, the points is difficult. You have to understand, look through before you can figure out. So your answer is right, but look at your explanation very well. Are you okay? Your explanation should look at the fact that the contour lines themselves tells you what's happening. When you see contour lines that are not evenly spaced, for example, so if you have contour lines going like that, which are not too close, it tells you that the area is flat, relatively flat. Okay, so there will be values in the 50. It takes a long time before you can have even another one which is really not that close in value. So here the interval is 4, if that's acceptable. Are you with me? Yeah, areas where you don't have, you can't have like a lot of mountain, you know, you can't have that thing happen. Accra is one of the places, but even then, when I'm moving from where I am to Kaswa, you know, I see a lot of undulation though, but relatively when you are in Kumasi, you need to make sure your car is a good car. Are you okay? Because you'll be going up a hill very soon. Can't just use any car. Are you okay? All right. Great. So let's go for tens. Are you okay? Tens. So 10 stands for triangular irregular network or triangulated irregular network. Is okay. I'm just going to write it. Okay. triangulated, irregular. Excuse me, let's work. Okay, so 10. The 10, are you okay? All right, what 10? This is triangles. You have triangles, and the facet of the triangle receives a value, and the value is based on the values at the vertices of the triangles. So you have a lot of triangles. Okay, so there'll be another triangle. So let's cover your face with a sort of triangles only. So the interesting thing about this, you can use this to actually so the triangles are only connecting at triangle vertices. So you see here, there's a triangle. I can do another one here. This can be used to create a surface. You look at it and you think, that's a mountain, isn't it? Oh, that looks like a very beautiful woman I'm looking at, but it's just triangles. It is used in cartoons. Anybody who loves cartoons, I want you to be aware that this is used to model some of the cartoon characters. Okay, but then the triangles are so small, you don't see that it's a triangle. Anyway, so that is another way. But obviously, you can see that our points of interest are actually at the vertices. Is that not so? So that you always need to start with some points. Either you interpolate them to make contours, or you actually create a 10 out of it. I'll show you an example of a 10. And so there you go. And then we have, last but not the least, the rasters. And I think we all understand how the rasters work. So the rasters will make use of some sort of algorithm. Are you okay? So algorithm is like a program. Are you right? That is written to, to obey certain instructions and to implement a set of instructions in a certain order. Now, what the algorithm will do is that it will simply take a certain area, check the number of points there. All right. It will center itself at all the possible points that you want to have values across that extent, and then interpolate and get a value, a very good value for where you are. So the algorithm will now visit all points and derive new values. Again, that's how a raster will be created. The raster, of course, that means that the algorithm will divide the whole area into squares. Are you okay? And then it will visit every square and give it a value based on neighboring points, okay, for which we want to create a raster, okay? So in other words, this is not even rasterization. There's something called rasterization. This is not rasterization. This is actually interpolation. Is that okay? So we need to take note of that. All right. Most surface analysis in GIS is done on raster or 10 data. Okay, so take note of that. Not on points. Contours are access opportunity. We talked about this already. Frequently created to represent surfaces on a map. Talked about that. Points can be regularly or irregularly. I talked about that. Distributed across a surface. Yeah, but it depends on why would we even want to have a regularly distributed points on a surface. I think this question, if I asked you, what would be your answer? Can I have a quick answer? Let me know whether you'll be passing this course. Yes, let me have a quick answer. Why would we prefer irregularly spaced points to irregularly distributed points? Yes, quick answers. Test yourself before the yes.
The irregular speed, it will help you to achieve your result earlier than irregular one. Irregular, have to do maybe a tabulation or whatever you call it. But if it is regular, easy for you to achieve your results when sending the regular.
That answer will not go. If you see your answer looks very political, it's easier. Okay, I want something more scientific. Kofi, okay, I want something more scientific. Is all right?
Yes, sir.
Kofi, think about it. I'm going to go here. Let's go to the board. And let me just ask you a question. When I ask you the question, your answer